So in this video, I'm going to teach you the concept of the binomial theorem. The binomial theorem basically is a theorem that will help us to expand an expression of the form x plus y to some exponent n. Or maybe if we use a different set of letters, a plus b, then raised to n. So example of this would be if, for example, x plus y raised to the 10. So if you want to expand x plus y to the 10, maybe one of the options will be you multiply x plus y times x plus y times x plus y, and so on until you produce 10 of the x plus y. And that will take us some time. So the binomial theorem basically will make the expansion easier. Okay, so to present the formula for the binomial theorem states that if I want to expand x plus y to the n, I need to compute the following values. So for now, you might not be comfortable with the notations, but let me just present it to you and then I'll teach you or explain it to you the meaning of each symbol. Because the expansion of x plus y to the n starts with n0, x to the n minus 0, and then y to the 0, plus n1, x to the n minus 1, y to the 1, and then plus we have n2, and then x to the n minus 2, y squared, and then plus n3, and then x to the n minus 3, then y to the 3. And then you have so many expressions that will follow this, but if you look at it, there is already an evolving pattern in the formula. Okay, if you notice, we started with n0, and this x is this x, and this y is this y. Now this exponent n is the number here. And then the exponent of x, if you notice, is just the difference of the numbers here, n and 0. And the exponent of y is the number here, which is 0. If you look at the other terms, the pattern is really like that. And then again, like I've said, there are following expressions after this, so we can expect the next to be n4, x to the n minus 4, and then y to the 4th. And then this could go a lot of terms until, actually, so this will end until you produce, so this is plus, until you produce n, when the n and the n are the same now, then x to the n minus n, and then y to the n. So you started with n0, you end with nn. Okay, so n0, and then you end with nn. So this seems to be maybe a bit complex to look at the formula, but when you recognize the pattern, the expanding of x plus y to some exponent will become easier. Okay, so let me apply this into a specific example. So suppose I want to expand x plus y to the 5th. Now, to those who are already familiar with the Pascal's triangle, this x plus y to the 5th can be easily expanded by using a triangle. Okay, but here in this video, I'm going to show how the binomial theorem can expand x plus y to the 5th. So I want you to take note that 5 here is our n, because that is the exponent. See, x plus y to the n. So our n here is 5. So if we follow the formula, we start with n, the 5, and 0. So we always start with 0. and then the x gets 5 minus 0 as the exponent, or simply 5, and then y gets the 0 as the exponent. See, these numbers here are coming here, so 5 and 0. Same with the 0, y to the 0, it gets the formula, it gets a value of the exponent from the number here. So if we continue, so just follow the pattern, 5, then you get 1, then x gets 5 minus 1, and y gets the 1. And then again, so just continue. So the following term will be 5, 2, and then x gets 5 minus 2, and then y gets the 2, plus this time 5, 3, and then x gets 5 minus 3, and then y gets the 3. And then again, just continue expanding. So the next will be 5, 4, x gets 5 minus 4, y gets the 4, and then plus 5, 5, and then x to the 5 minus 5, and then y to the 5. So you will know if you will be ending the expansion once these numbers here are already the same. So 5 is the same as 5, so we stop the expansion here. Okay, now just something that I want you to note: when we expanded x plus y to the 5th, we were able to produce 6 terms, and that is first, second, third, fourth, 5th, and then 6th. And that's always the case for when you expand a binomial. The number of terms is always 1 more than the value of n. So if I raise x plus y to the 10, then I'll expect 11 terms. And note, there's also a pattern in the term. Like in this case, the first term has a 0, the second term has the 1, the third term has the 2, the fourth term has the 3. So the number below is always 1 less than the corresponding term. Like in the 6th term, the number here is 1 less than the corresponding term. So 6th term, you have the value here as 5. Okay, so later on you'll encounter a special formula in finding a specific term, and understanding it here will be important in understanding that new formula. Okay, but for now, what I want you to understand is how we can expand a binomial through the binomial theorem. Okay, so how do we exactly get the values of each term? Because this is just a setup in finding the expansion. So what will happen next after this? So carefully solve each value or simplify each value, starting with the first term. Now 5, 0, so let's have some side note here. When you work with 5, 0, this is actually 5, C, 0, and this can be obtained or can be calculated using a calculator. All you have to do is to find the function NCR, where you have to input n as 5, and then you have to press the button NCR. Sometimes you have to press the shift to reach that key or button, and then the corresponding value for R, which is 0. And if you do that, so I'll just show you now the exact value that you will get. So going back here, 5, 0, when you compute for that, that's basically 1. Okay, and you can try that on your own. And then x, so I want you to focus on the first term. Okay, this is the first term. then x to the 5 minus 0 is the same as x to the 5, because 5 minus 0 is 5. And then y to the 0, any number, non-zero number raised to 0 will become 1. So that's just basically times 1. Okay? Or you can just omit that, because times 1 will make the value the same. And then you move on to the next. So plus, okay, so 5, 1. So focus here. I need you to focus on the second term. We need to simplify that. So 5, 1, use a calculator to find it. Once you press 5 and then button NCR number 1, you will see that the value is 5. Then simplify x to the 5 minus 1, you get x to the 4, and then y to the 1 is simply y. Then you continue. Okay, so you go now to the next term. You just repeat whatever you are doing to each term. So compute for 5, 2. 5, 2 is basically 10. If you do the NCR button, 5, 2 is basically 10. Okay, and x to the 5 minus 2 is x cubed, and then y gets the exponent squared. Okay, so we're almost there. And then continue with the fourth term. So what will be the fourth term? So the fourth term will be compute for 5, 3. So for the 5, 3, you'll get, so we have plus 5, 3, that will also be a 10. Okay, so you just have to compute for that. Then x to the 5 minus 3 will be x squared, and then y gets a cube. And then continue. So we're down to the second to the last. So this is your next task. So this is plus 5, 4. If you compute that again, you'll get 5. X to the 5 minus 4 is x to the 1. And then y to the 4th is simply y to the 4th. And finally, we're almost there. 5, 5, when you compute for that, that's 1 basically. Then x to the 5 minus 5 is x to the 0. And then y to the 5th is just y to the 5th. So after that, all you have to do is to fix some of the terms. When I say fix, if you can simplify it further, then simplify it further. Like in the case of the first term, that's 1x to the 5th times 1 is basically x to the 5th. And then plus, so we just copy 5x to the 4th, y, we copy 10x cubed, y squared, we copy 10x squared, y cubed, and then plus 5x y to the 4th. And finally, we have 1 times x to the 0. X to the 0 is basically 1. So the last term should be plus y to the 5th. So you might say, oh, I can simply do that using the Pascal's triangle. So please note that I am using x plus y to the 5th for you to easily follow how to use a binomial theorem. Because later on, you'll encounter something that has an n that is bigger than, say, 10. And using the Pascal's triangle will not be the best option to use. Okay, you don't want to create a Pascal's triangle just for, or so maybe if you have x plus y to the 20. And that will, you can expand it, but it's not the best option. Okay, so I do hope that you understand how to apply the binomial theorem, or how the structure of the binomial theorem is. And hopefully when you expand a binomial on your own, you'll be able to apply it effectively. Okay, so always remember the key values, like what is my n, how do I start my number. For example, in this case, remember we have to start with n0 and then n1 and then n2. So you see here n1, n2, n3, n4 until it becomes n5. Okay, or and when they become the same. Okay, so I think that's it. So I hope you understand my explanation.